Alright, CNT125, Chapter 8. Before we start digging into subnetting, I like to hit what I call subnetting fundamentals, some things that we need to kind of have in our brain before we even tackle the idea of taking our IP address pool and subnetting it. So, a couple things we need to make sure we have straight in our head. First is the network address or network ID. This is the number that identifies the network. If I had to relate this to a city or a town, if I use the example of Main Street in Mechanicsburg as opposed to Main Street in Dayton, Ohio, you notice I don't have any house numbers or anything like that on. I don't need that to identify the street. There is only one Main Street in Mechanicsburg, PA on the entire globe. So as long as I say Main Street, Mechanicsburg, PA, that's the only one. And that would be as opposed to the Main Street in Dayton, Ohio. Again, there's only one Main Street in Dayton, Ohio. So that is identifying the street in a town in the world. The network number or network address is identifying the network in the world. And to do that, the host portion of the address gets set to all zeros to identify the network. So 95000 is identifying the 95000 network. And nodes, 95.32.12.16 are belonging to the 95000 network. If it's a Class B, I'd have a 135.50.0.0 network. Class C, 195.32.12.0 network. Why is this important? For one, it identifies the network. We often have to do that. We often have to identify the network. There's times we even need to tell the routers, routing protocols if you think back, what network something is on or what network we should pay attention to for routing updates. That often gets used. The second reason this is important is that's a number we can't actually assign to any host or node or server or router port or anything like that. I can't actually assign that number to anything. It's used an identifier. And if I go back to my street example, there's no house in Mechanicsburg that their house address is Main Street, Mechanicsburg, PA. No, it actually is a house number, 125 Main Street, Mechanicsburg, PA. We got to put a house number on it to identify that house. So I can't just identify a house as Main Street, Mechanicsburg, PA. That's not enough information. That is the street address, not the house address. So again, 95000 is a number to identify the network. I can't use that to assign to a node. Okay, so your network number and network address, first important piece to remember before we start subnetting. Next one we have is the broadcast address. Broadcast address is a number that is used to send a message to all nodes on either the whole network or the whole subnet of a network. And to do that, the host portion gets set to all ones. The host portion of address gets set to all ones. So, if I have the 95000 network, if I want to send a message to everybody on that network, the following address is going to get used, 95.255.255.255. That is an address that can get used to send a message to everybody on the 95000 network. Same thing on a Class B 135.50 network. If I use 135.50.255.255, that is an address that can get used to send a message to everybody on the 135.50.0.0 network. Last one, 195, if I have a Class C, 195.32.12.255 is an address that can get used to send a message to everybody on the 195.32.12.0 network. Okay? And that happens. There's protocols that do that. Things boot up and ask for addresses, and protocols send messages out saying, hey, I'm looking for. This happens. This gets used. So why is this important? Again, this is a number used to send a message to every node on that network or subnet. Also, this is a number that cannot be assigned to a host or node on the network. We cannot use that to assign to a host or node on the network. Two important numbers, your network number and your broadcast number. Network address, broadcast address. Two important numbers to make sure we know. Third and final that's important is our host or usable address. So if I actually want to give an address to a house on Main Street, Mechanicsburg, PA, I would say 123 Main Street, Mechanicsburg, PA, or 124 Main Street, Mechanicsburg, PA. Again, with all the pieces there, we have the street and town and the house number. There is no other house on the planet that is 124 Main Street in Mechanicsburg, PA. There is no other one. Okay? That's it. That's all it exists. So that would be a usable node, a usable address on a city, usable address for a house in a city. If I translate that into networks, a host portion, or I should say a host address, when I have a host address, the host portion is not all zeros, because that'd be a network number, and it's not all ones, because that'd be a broadcast address. So as long as it's not all zeros and not all ones, it is a valid host address. So 95.25.5.15 is a valid usable host address for a node on the 95000 network. Same thing here on the Class B, 135.50.25.5. That is a usable node on the 135.50.0.0 network. Last but not least, Class C network 195.32.12.5 is a usable host or node on the 195.32.12.0 network. Okay, and again, why is this important? Here are finally the numbers or addresses we use to assign to hosts, nodes, printers, servers, access points, IP phones, etc. Things on my network. These are actually the addresses I use to assign to them, these host addresses. So real quickly, remember your network number, host portion is all zeros. Broadcast address, host portion is all ones. A usable host address is, the host portion is not all zeros and not all ones. Okay, these are the ones I can actually use to assign to things in the network. We need to make sure we have those squared away in our brain. Second piece of subnetting fundamentals is, subnetting is really just equal size groups of numbers. That's all it is. So if I was working with numbers that went, IP addresses that were in the range of 0 to 100, all of our addresses were, 100.100.100, and everything just went from 0 to 100, this would be easy peasy. Because if I said to you, oh, I need 4 subnets, say, oh, okay. 0 to 25, that block of numbers is the first subnet. 26 to 50 is the next block of numbers. 51 to 75 is the next block of numbers. 76 to 100 is the next block of numbers. Easy peasy. Sets of 25. Cool. There's my 4 equal pieces. There's my 4 subnets. Easy peasy. That's all subnetting is. Equal size groups of numbers. Almost like taking a pie and cutting it in equal pieces. That's all it is. That's all subnetting is with our number pool. The catch, though, is we're not dealing with 0 to 100. We are actually dealing with 0 to 255. But I'm going to do the exact same thing. I'm going to take 0 to 255 and I'm going to break it into equal pieces. 0 to 255 broken into 4 equal pieces can be done. It's going to end up being 0 to 63. There's 64 numbers. 64 to 127. There's 64 numbers. 128 to 191, there's 64 numbers. 192 to 255, there's 64 numbers. So there's 4 equal pieces of 64. These would be my 4 subnets for this network if I had to break it into 4 pieces. So that's all subnetting really is. I take a pool of numbers and I break them into equal pieces. It's got to be equal pieces or routers, switches, things don't understand. They don't understand the odd pieces. They need to be equal pieces, if you will. In this case, we're broken into 4 equal pieces of 64 to get the job done. So to do this, a network administrator can borrow bits from the host portion to create a subnet portion. So we're used to having the network piece and the host piece. I can actually steal a couple bits from the host portion and create a subnet piece. And that allows me to break this into equal pieces, take a block of numbers and break it in equal pieces. So if I expect the subnet mask to be 255.0.0.0, I can actually do 255.224.0.0. This 224 is stealing a couple of bits from the host portion to give me a subnet piece that's going to allow me to break my network into equal pieces. Again, if I expect my subnet mask to be 255.255.0.0, I can borrow a couple bits and create this 240 right here. I stole a couple bits to create a subnet piece. And same thing out here with a class C. If I expect 255.255.255.0, I can steal a couple bits from that 0 portion, make a subnet portion, and create subnets, create blocks of numbers, if you will. So to do this, I do have 2 rules that I need to follow. One is bits are always going to be borrowed left to right in the host portion. The other one is 2 bits must remain when I'm done borrowing. So I borrow left to right, and I gotta leave 2 behind. Okay, so let's take a look at the left to right thing. Bits are always borrowed from left to right. So if I have a Class A network, subnet mask 255.0.0.0, here's my host portion, those 3 zeros written out in binary. I can start borrowing bits right here and go this way to create a subnet piece. So I originally had 255.0.0.0. I can do the 240 here, and you notice I'm borrowing these first couple, and it has to be from here left to right. That's how it's got to be. And that is going to create me my subnet piece. So now 255.240.0.0 is going to give me the subnet piece. If I had a subnet mask of 255.255.0.0, here is the host portion, all zeros. I can start borrowing here and going right. So I can take these first 3 bits from this octet, create a subnet piece, the remaining will be host, and I end up with 255.255.224.0. Last but not least, Class C, if I have a 255.255.255.0, the host portion, here's my last octet, all zeros, I can start borrowing here and go right. So I could take those first 2 bits and create a subnet block or subnet piece, and my subnet mask becomes 192 representing that. But you notice every time I'm starting left and going right. That's the first thing I have to do. The second one is when I'm done, I have to have 2 bits left behind. I need to leave 2 bits behind. Example, if I have a subnet mask, a Class C 255.255.255.0 subnet mask, host portion of 8 zeros here. If I borrow left to right, which I'm doing right here, I start borrowing and I borrow up to 6 bits. I can do that. I'm borrowing left to right. I'm not breaking any rules. I got to leave these 2 behind. And why they set the number 2 is like so. If I take those 2 bits in binary, I'm going to nerd out and do it in binary. If I take those 2 bits in binary and put them right here and start writing up, counting up in binary, 0, 0, 0, 1, that's 1. 1, 0 is actually the number 2. 1, 1 is the number 3. So 0, 1, 2, 3. That's what I got. I got 4 possible combinations. Well, if I follow my previous rules, all zeros in the host portion is a network ID. I can't use it. All ones in the host portion is a broadcast address. I can't use it. The only 2 usable addresses are these in the middle, 0, 1 and 1, 0. I got 2 usable addresses. That's it. And if I think it through, one of those is going to get assigned to a node, one of those is going to get assigned to a default gateway. So it is usable. I can do this. Sometimes it's even done because I have a router link, a link between 2 routers, and that's the only 2 addresses I need. This first router on this side, this router on the other side. This would work. It is perfectly usable. But the reason they're saying that is I can't go more than that, because if I did, I wouldn't even have this many. So I can borrow left to right, but when I'm done, I have to leave 2 bits behind. I gotta, no matter what. That's why that second rule applies. Okay, so with a Class A address, I have 24 bits to work with. I could borrow up to 22. Class B, I have 16 bits to work with. I could borrow up to 14. And a Class C address, I have 8 bits available. I could borrow up to 6 if I need to. Okay, that's what that allows me to do. And these are the 2 rules. Borrow left to right from the host portion, and I gotta leave 2 bits behind when I'm done. Those are my 2 guiding rules for subnetting. Okay, those are the 2 guiding rules for subnetting. All right, next podcast we're going to talk planning. How do I figure out how many bits to borrow to plan out my subnets?